So we're going to talk about two-way tables and how to get probabilities from two-way tables. So before we start, I'm going to get some row totals and column totals. So the scenario says that a random sample of Savannah Arts Academy students were taken. And we're going to use this same scenario throughout the presentation. So let me get some row totals here. We have add up 4, 45, and 32. That gives us 81. Add up 35, 70, and 65. That gives us 170. And I would also do column totals. This is 39. This is 115. And this is 97. Now this cell represents total students. We could take the number of male students, which is 81, and add the number of female students, which is 170. We get 251. Now we would get the same thing if we added the number of dance majors plus visual arts majors plus theater majors. We should get 251. So if you're not given these values, that's a good checkpoint, and make sure that this row is the same as this column. Okay. So to answer the question, what is the proportion of students who are males? We have 81 males, and we have 251 students. So the proportion of students who are males would be 81 out of 251. Another way that this question will be worded is, what is the probability that a student is a male? And that would be the same way. 81 divided by 251. So let me clear these. Now we'll have these values. Look at another. What is the proportion of students who are dance majors? So dance majors is this column. There are 39 total dance majors. There's 251 total students. So that fraction, 39 divided by 251, or whatever that equivalent decimal is your proportion of students who are dance majors. So the first two are pretty straightforward. Now let's look at this. What is the proportion of students who are female or visual arts students? So first let's do this. If they're female or visual arts, I'm going to highlight them. So female, and also visual arts. Still female, and this person's visual arts. Now in statistics, when they say or, unless specified, we're talking about inclusive or, which means this person could be female, they could be a visual arts student, or they could be both. So if we added up these four numbers, 45 plus 35 plus 70 plus 65, that gives us 215. So 215 of these students are either female or visual arts students, and there are 251 students. So that would be our probability, would be 215 out of 251. Okay. And I'll leave that there. I'm going to come back to this problem. First I want to show this formula. This says the probability of A or B. This is called union. You can remember that because it looks like a U. But what it means, and for our purposes, is or. What is the probability of A or B? And this formula says we can add the probability of A plus the probability of B, as long as we subtract away the probability of A and B. This symbol is called the intersection, which means and. So let's go back to what we were talking about here. Let's look at this formula. So A is going to be female, and B is visual arts students. What we're saying is the probability that we're female or visual arts. So we'll do the probability. I'm going to use this formula and show that the formula holds. Now, definitely the easiest way to do this, if you're looking at a table, is to do what we just did. Add up those four numbers, divide by the total, that is your answer. But sometimes we're going to be forced to use a formula. So I just want to kind of show where this formula comes from. So A or B. And I think a table is a good way to show it. So the probability of A is the probability that we're female. So female is 170 divided by 251. Plus the probability of a visual arts major, which is this column, 115 divided by 251. And then we have to subtract away the probability of being female and visual arts major, which is this group right here. This group satisfies both of those. So they got to subtract away the 70 out of 251 students who are both. Okay. And if we do 170, you can see 170 minus 70 is 100, and then 100 plus 115 is 215 out of 251, which is what we got when we looked at the table. So if you understand what's happening here by subtracting this, we're just making sure that we don't count it twice. We're making sure we don't count this group twice. So if we added up all these, we get 170, plus add up all of these, we get 115. But we got to remember to take this group away because we don't want to count them twice. So, next question. What is the proportion of students who are female dance students? Now, this doesn't look like it might be an intersection problem. It may not look like it's an intersection problem, but what they're asking us is, what is the probability of A and B? It's got to satisfy both of these characteristics. Well, we just talked about that. The only cell in here that satisfies both female and dance students would be this 35 students right here. They're female, they're also dance. So it's the probability of both of these events being met. So our final probability is the 35 students out of the 251 students. Okay, same thing here. What is the proportion of visual arts majors? Oh no, this is actually a different question. This is what we call conditional probability. So in these problems, you're basically given a condition and then asked to find the probability out of that condition. So it says, what is the proportion of visual arts majors that are male? So if you read that carefully, what that says is, if we look at visual arts majors, if I only look at visual arts majors, what proportion of those are male? So that would be 45 male out of the 115 visual arts majors. So that would be my proportion. So 45 out of 115. I'm only looking at this column. Okay, what is the proportion of males who are theater majors? Proportion of males who are theater majors. So in other words, now our condition is not an arts major, it's a gender. We're given that we're male. What is the proportion of the males who are theater majors? So we're looking at the 32 male theaters majors out of the 81 males. So 32 divided by 81 would be our proportion or our probability for that event. And the last thing I want to show you, or second to the last thing I want to show here, this formula, which you'll have to use, is the conditional probability formula. And what this says is the probability that A given B, remember B was our category or our event that was locked in from the beginning. So given B is the probability of A and B divided by the probability of B. So notice that whatever, this is your new universe is what I like to call it. If you're given that you're in terms of B, you're only going to look at event B. So if we go back to that, you'll kind of see why this formula makes sense. So write it here again. It says the probability of A given B is the probability of A and B divided by the probability of B. So again, I'm showing this with the table. We've already gotten our answer, but I'm showing this with the table because eventually we're going to have, or some problems, we're going to have to use these formulas. They need to make sense to us. So what this says is the probability of A given B. So the proportion of males who are theater majors. Now what we're talking about is what is the proportion of being a theater major given that you're a male. So B is actually given that we're a male. So notice that we're dividing by the probability of B, which we're only which is males. We're forced to that category. So let me show this. We have the probability of A and B, which is males and theater majors, which is 32 out of 251. Put that here. This is the probability of both male and theater, okay, divided by the probability of B, which is the probability of our given, which is male. So our probability of a male is 81 out of 251. Or, yeah, 251. This is also 251. 32 theater and male theater student, 32 out of the 251. So if we're dividing a fraction by a fraction, we know we can multiply by the reciprocal. So what I'm actually doing here is I'm multiplying this by 251 over 81. Okay, this goes away now. And the 251s divided by, or 251 divided by 251 is 1. So what I'm left with is 32 out of 81, which is what we got when we looked at this formula, or when we looked at the table originally. We said, given that we were male, we were in this group, the probability of being a theater major was the 32 out of the 81. So the last thing we're going to look at here is determining whether two events are independent. So what this says is, are the events dance major and female independent? Now what independent means is that one event doesn't affect the likelihood of the other event. In other words, does the fact of being female, I guess we shouldn't say change the probability, but does it have some kind of effect on the probability of being a dance major? So if there is no effect, in which the two are independent, what will happen is the probability of A given B will be the same as the probability of A. Okay? And I hope you take some time to think about what this actually means. If two events are not related, which means they're independent, then regardless of whether you're looking at your given B, the probability of A is the same. So in other words, let's give it some context here. Let's say, what is the probability that a female, given that a student is a female, what's the probability that they're a dance major? So we're only concerned in this probability here, formula, we're looking at females. Of the females, what's the probability of being a dance major? Well, it's 35 out of 170. Okay? Given that they're female, what's the probability of being a dance major? Okay? So what we're trying to see, is that the same thing as the probability of being a dance major? In other words, given the fact that we're female, did it actually have an effect on it? So, is this the same as the probability of being a dance major? Well, that probability is there's 39 dance majors and there's 251 students. So now we're looking at we're not having a condition, we're looking at all students. And what you're trying to do is see if these two probabilities are the same. And I'm not going to show the calculator here, but you can check it if you want. This is more likely. 35 out of 170 is a higher percentage than 39 out of 251. So what that tells us is that they're not independent. In fact, being female and being a dance major have some kind of relationship. And the relationship may be that if you're a female, you're more likely to be a dance major than if you're anybody from the general population, which means males and females. Okay? So that fact shows that, and again, you can check it in a calculator, but it shows that these two events are not independent.